Hi, I'm Helen Dakin, and today what I'd like to do is talk to you about general annuities. General annuities differ from ordinary simple annuities in that the annuity payment periods do not coincide with the interest periods. That is, if we have payments that are made monthly and the interest is compounded semi-annually, as is often the case with mortgages, we have a general annuity. That is, the number of payments per year does not equal the number of interest periods per year. The focal date for the future value of a general annuity or any other annuity is on the same date as the date of the final payment. So here we have a time diagram with a general annuity and end payments, and we have the focal date for the final value. Now we know that the final value formula tells us that the future value of any annuity is equal to the total of all of the payments plus the accrued interest, and that can be calculated by R multiplied by the annuity factor 1 plus I to the exponent n, subtract 1 divided by I. But what's key here is to note that the interest periods per year, I, and the number of payments per year for the payment size, or R, must coincide. And if they don't coincide, we need to make them coincide. So this can easily be done by adjusting to an equivalent interest rate. And again, taking a look at the next time diagram for the present value, the focal date for the present value is one interest period or one payment period before the first payment is made. And you can see here we have the focal date one period before the first payment is made. And the present value formula is simply the discounted value, or the value without the accrued interest of the payments. So it's a discounted value of all of the payments, and that would be R multiplied by the discount factor for ordinary simple annuities. That would be 1 minus 1 plus I with a negative n exponent. N is always the number of payments per year divided by the interest rate. So in conclusion, when you're faced with a general annuity, when the payment periods don't coincide with the interest periods, you will need to take a step aside and convert to an equivalent rate, an interest rate which is calculated as often as the payments are made. This can easily be done on your BA2 Plus calculator. Note that with the BA2 Plus calculator, you will pay particular attention to the following parameters. N is always the number of payments in the annuity. IY is the nominal interest rate. You will need to enter the compounding interest periods per year separately by going second function IY. CY is the interest periods per year, that is compounding interest periods per year, and PY is the payments per year for the general annuity. Go second quit again to get out and get back into the normal operating mode for your financial calculator.